Alright guys, so we've been working on these one-dimensional motion problems and figured I'd stop here and do a couple problems for you, make sure you feel good about it, and got some ideas of how to work everything out. So what I'm going to do from page 84 in your textbook, it's number 86, sorry about that, my throat. It's number 86. And 86 reads as this: suppose a spaceship far away from any star or planet has a uniform forward acceleration from 65 meters per second to 162 meters per second in 10 seconds. How far would the spaceship move? Okay, so in this, got some spaceship. I'm just going to draw it as a box and call it a spaceship. That's my spaceship. And it starts out with some sort of velocity, so it has this initial velocity, and that initial velocity, we're just going to call it the x direction to keep everything simplistic. So this initial velocity in the x direction, okay, it is equal to 65 meters per second. I know that because of my problem. Well, my problem had told me it has a uniform forward acceleration from 65 meters per second to 162 meters per second. So, and then I know with this some additional information is my final velocity in the x direction is equal to 62.0 meters per second. So now in this, pretty much all the information I got right here. So let's start looking at our SHOPA list. So let's just fill it all in. So I'm going to put my initial position, my final position, my initial velocity in the x direction, my final velocity in the x direction, my acceleration, and time. Okay, so from this, can we tell anything what's going on? Can we start filling in some information here? So what about this initial position? Do we know the initial position? It didn't say it in the problem. Nowhere in there does it talk anything about it, our initial position in the problem, but we can. I'm going to say my initial position is 0 meters. Why? Because this is me. I'm setting my axis. This is my reference point, and I'm saying if I'm measuring from this point, that right here is 0 meters. I'm starting out right there. That's going to be 0 meters. But now, do I know a final position? I do not know a final position, because it does not tell me any more information in the problem for me to know a final position. Do I know an initial velocity? Yes, it gave me my initial velocity to be 65 meters per second. Then I have a final velocity, which is 162.0 meters per second. An acceleration, do I have it? No, but I'm trying to find it. And then I have time. Do I have time? I do. If you paid attention to the question where it says how far would the spaceship move, it told you that it had that uniform forward acceleration from 65 meters per second to 162 meters per second in 10 seconds. So 10 seconds. And I am tasked with how far would the spaceship move. So I'm trying to find that distance that that spaceship's going to have. Now, in this, let's see, I'm thinking of which equation I would go for. Well, let's just throw them up here for a minute. So let's do final position equals initial position plus initial velocity times time plus 1/2 times acceleration times time squared. So I have that one. I'm looking at that one. I'm also looking towards this final velocity squared is equal to my initial velocity squared plus 2 times acceleration times the change in displacement, which is x final minus x initial. And I'm looking at that because that also has my positions in them. So whenever I'm looking at this, I'm going to start looking and seeing what I can solve with. Remember the box and circle method? So I'm going to start up here. I don't know final position. I'm looking for it. I know initial position. I have an initial velocity. I have a time. I have an acceleration. No, I do not have an acceleration. And I have time. So I have a problem here. I have two boxes. Two boxes tell me I can't solve it without a secondary equation. So let's look at this one here. I have a final velocity. I have initial velocity. I have no acceleration. And I'm looking for the final position, but I do know my initial position. So in this, either way I'm going to have to end up using, the other equation to figure it out. And the other equation I'm talking about is that final velocity equals initial velocity plus acceleration times time. And the reason I say that I have to use that is because what am I missing in both of these? I'm missing acceleration. So I have a final position, I have initial final velocity, and an initial velocity, sorry. I do not have acceleration, but I have time. Therefore, I can solve this. So here's what I'm doing right now is what I've worked with you in class before. I'm figuring out a plan, a way to solve this. So I started here trying to find this, and I figured out I can't solve it for just that, so I keep reaching in my toolbox for more tools. So now I have a plan together. First thing I want to do is I'm going to do this equation. I'm going to rearrange it, get acceleration, find acceleration, and then I'll do this one because I got a feeling you are more comfortable with that one. So here's what we'll do. We'll have the final velocity is equal to initial velocity plus acceleration times time. Now in this, I'm trying to get my acceleration by itself. So I will subtract my initial velocity from both sides. So final velocity minus initial velocity is equal to acceleration times time. All I did is subtracted the initial velocity there. And now I have the acceleration by itself. I'm going to do two steps here. I'm going to get acceleration is equal to the final velocity minus the initial velocity divided by time. So in that, all I did is I divided both sides by time. And then I just flipped it because I like what I'm trying to find on my left. So now let's fill in some information here. Final velocity is 162 meters per second minus my initial velocity, which is 65 meters per second. And that's all divided by my time, which is 10 seconds. And sadly, I do need a calculator for that. So 162 minus 65 divided by 10. So we find that our acceleration is 9.7 meters per second squared. Yes, I will take points off if you do not put your units, because if you don't put units, then you are wrong. So now I have this acceleration. Am I done? No, that was the first step. That was the first thing of the problem. Now what I have to do is I have to go back and plug it into this equation for me to find everything that I'm looking for. So I'm going to do this one in purple. Hopefully this is showing up on the screen. But I have the final position is equal to my initial position plus initial velocity times time plus 1/2 times acceleration times time squared. So this will be equal to, my initial position is 0. So I'm not going to fill in for it, but I do have an initial velocity of 65 meters per second times time, which is 10 seconds, plus 1/2 times acceleration, which we saw to be 9.7 meters per second squared, times time squared, which is 10 seconds squared. Now I'm not going to go individually and do that. I'm going to punch it all in the calculator all together. So let's do 65 times 10 plus 0.5 times 9.7 times 10. And it'll be 698.5 meters. And there is my final answer. So the answer for 86 and how far would the spaceship move? It's going to move 698.5 meters. If you have any questions about this problem, how I did it or how I've done others, come see me, guys. Come see me before we take this quiz. You need to come see me because it just gets harder from here.